Namaste children. Now I am going to explain some proof questions based on laws of exponent. The question is we have to prove here x to the power of a upon x to the power of b raised to the power a square plus ab plus b square into x to the power of b upon x to the power of c raised to the power b square plus bc plus c square into x to the power of c upon x to the power of a raised to the power c square plus ac plus a square is equal to 1. We have to prove. So this is the LHS. I'll take this is LHS, this is RHS. So LHS should be equal to RHS. Then only we can verify the proof. Now listen, how you will use laws of exponent here. Listen, how will you use laws of exponent? You know that students, you know that, listen here, you know that x to the power of a divided by x to the power of b is equal to x to the power of a minus b. This laws of exponent you have studied. So here I will apply that one. X to the power of a, this is divided by upon x to the power of b. So this one you can write x to the power of a minus b. Then raised to the power, how much is there? A square plus ab plus b square into, similarly here you can write x to the power of b minus c again raised to the power b square plus bc plus c square into, same here x to the power of c minus a raised to the power c square plus ac plus a square. Now students, you know that again a to the power of m whole to the power of m is n is equal to a to the power of mn. Similarly, these two exponents you can multiply according to laws of exponent. So this one you can write x to the power of a minus b into a square plus ab plus b square. Similarly, into x to the power of b minus c into b square plus bc plus c square into x to the power of c minus a into c square plus ac plus a square. Now students, you know that aq minus bq formula. You already know that aq minus bq formula. You already know that a cube minus b cube is equal to a minus b whole into a square plus ab plus b square. Similarly, in place of a minus b, a square plus ab plus b square, you can substitute a cube minus b cube. So you can write x to the power of a cube minus b cube into, again x to the power of, this one you can write b cube minus c cube, because b cube minus c cube formula b minus c into b square plus bc plus c square into, this one also you can write x to the power of c cube minus a cube. Now listen, you know that according to laws of exponent, if base are same, then in case of multiplication the exponent you will add. So this one you can write x to the power of these three exponents you have to add. So a cube minus b cube plus b cube minus c cube plus c cube minus a cube. Now all are cancelling, that is x to the power of 0. You know that something to the power of 0 is how much? 1. So that one is equal to RHS. Is it clear? Now students, I'll prove another question. 1 by 1 plus x to the power of a minus b plus 1 by 1 plus x to the power of b minus a is equal to 1. So first write LHS. LHS is equal to 1 upon 1 plus x to the power of a minus b plus 1 upon 1 plus x to the power of b minus a. Again I am saying x in place of x to the power of a minus b, you can write x to the power of a divided by x to the power of b according to laws of exponent. In case of division, you have to minus. So 1 upon 1 plus, this one you can write x to the power of a divided by x to the power of b plus 1 upon 1 plus, similarly here x to the power of b divided by x to the power of a, because in case of division the exponent you have to minus, so b minus a. So now 1 upon, here you can take LCM, first solve this part. Here LCM, here no number means 1 is there. Here LCM is x to the power of b, x to the power of b you will multiply here, you know how to add x to the power of b, here x to the power of a. Similarly 1 plus, here no number means 1 is there, so here LCM is x to the power of a, x to the power of a multiply here x to the power of a plus, here already x to the power of a, x to the power of a is there, then remaining is x to the power of b. Now, so you can write this one. Again, this part, if this division you will make into, then in the down it will be reciprocal. So this one you can write x to the power of b divided by x to the power of b plus x to the power of a, because you know that 1 by a upon b is equal to, this one you can write b by a. Similarly this one you can write x to the power of a divided by x to the power of a divided by x to the power of a plus x to the power of b. Again you can take LCM, this one are same, so you can take LCM as a x to the power of a plus x to the power of b. Here this one will be divided, means 1 will get 1, if you will multiply here you will get x to the power of b, here you will get x to the power of a. Now both are equal, if you will cancel you will get as a 1, so that is RHS proved. Clear? Now students, I'll explain another proof questions. The question is x to the power of a minus a to the power of minus 1 whole again raised to the power 1 upon a minus 1 again raised to the power a upon a plus 1 is equal to x, we have to prove. This is LHS. So LHS, so listen how to solve this one. You know that according to laws of exponent, these two exponent you have to multiply first. If you will multiply, this one will be x to the power of a minus a to the power of minus 1 again raised to the power, these two multiply according to laws of exponent, again these two you have to multiply. If you will multiply a into 1, so a divided by a plus 1 into, if you will multiply a plus 1 into a minus 1, again that one you can write x to the power of a minus a to the power of minus 1 raised to the power a divided by a plus b into a minus b, formula what, a square minus b square, that is a square minus 1. Again a plus b into a minus b formula. Again according to laws of exponent, again these two exponent you have to multiply. Again x raised to the power a into a minus a to the power of minus 1 divided by a square minus 1. Again x raised to the power a into a square minus a into a inverse is how much? 1. Remember, a into a inverse is equal to a into 1 by a is equal to 1. So a into a inverse is equal to 1. A into a inverse. So denominator is a square minus 1. So while cancelling, give bracket and cancel. So this one cancel. X to the power of 1 is equal to x. Clear? So this is the how to use the laws of exponent. This should be your creativity, how I am solving these questions under. Okay, so like that you have to solve, and first you have to know the laws of exponent. Here let me clear one more thing. Some students, if they have doubt, why sir here you wrote 1, why not x to the power of 0, where it will be x to the power of 0. Remember, suppose in the case x to the power of x minus a plus suppose x minus a, suppose x to the power of x minus a minus x plus a, in that case if we will cancel, here will be 0, because here in case of division, suppose I am dividing 2 by 2, that means you can get 1. Similarly, in case of division you will write 1. Addition and subtraction it will be 0. Addition or subtraction it will be 0. If x to the power of 0 it will be 1. Here x to the power of 1, that means x. So that one is equal to RHS. Clear?